Ours is a world of movement, of hurtling, headlong change. The impact of science on our world is incalculable. Today, technological progress proceeds at a breathless pace. But such development has rarely been the result of lone endeavor. For more often than not, it's the outcome of the combined efforts of people working in groups, teams, and organizations. In Brussels is one such body. This is the home of NATO, the North Atlantic Treaty Organization. Here are those whose task it is to safeguard the democratic ways of life of the Alliance's 16 member countries. The defense and political stability of this vast area are NATO's primary roles. But within these walls is to be found a third dimension of vital importance, a foundation designed to promote science as a means for our Western world to stay in the forefront of economic, technological, and human endeavor.
I'm pleased to see you again for this NATO Science Committee meeting.
Here meets the NATO Science Committee, a body representing the Alliance's scientific community. What the Science Committee recommends is taken up and implemented by the Scientific Affairs Division. Such recommendations support people and projects. It all adds up to the toing and froing of thousands of scientists from one alliance nation to another, and has been likened to a vast yet invisible university. This invisible university has many roles, and one of the largest is to supply the means for students from any alliance nation to pursue further studies in another country. One such individual is Andrew Barlow.
I came to New York about 6 months ago to study at Columbia University. While completing my doctoral studies, I heard about the NATO postdoctoral fellowships. The competition is intense and selection involves submission of a research proposal and acceptance by the proposed university. I considered Columbia to be a very attractive university. It has a chemistry department which is small, but is internationally renowned in my own field of organic chemistry. And also there's a very good atmosphere among the faculty. I'm working on the total synthesis of a naturally occurring substance, which is an indole alkaloid called reserpine. This compound has been used clinically in the treatment of schizophrenia, and more importantly, as an antihypertensive.
Which reaction is this?
Well, this one is an alkylation reaction, or it would be nice. One sees a very different approach to research compared to England. And New York is very vigorous, very different. We have a large research group, 25 people, and it's very stimulating to be able to exchange ideas with such a number of young people.
Andrew Barlow is but one of many, for annually over 1,200 fellowships are awarded. Another going to Maria Castellino from Spain, the Alliance's newest member country. Maria Castellino, a medical student, is halfway through 2 years' research at the University of Milan's Grossi Paoletti Center, where she studies the causes of strokes and heart disease. She works alongside a team acknowledged as one of the most advanced in the world, as they attempt to reduce the risks and unravel the many mysteries surrounding the West's largest single killer disease. Since the inception of the fellowship grants, over 20,000 students have gone abroad, studied, and absorbed the culture and knowledge of others. At Hull University in northeast England, Klaus Selke, a German, is taking advantage of a different program, a cooperative research grant.
What is the alignment? It's about 5 degrees?
A bit less than that now.
These short, reciprocal visits enable scientists to carry out common projects with colleagues who are among the best in their chosen field, which in Klaus Selke's case is the futuristic and demanding world of applied robotics.
I think we need to adjust that vacuum sucker a little bit.
Yes, it twists when it's up in the air.
Well, Klaus, you've come in here to have a look at the work we're doing in air recovery. This is, in fact, in conjunction with the University of Waterloo. That's in Canada, of course, in the province of Ontario.
In the same department is Mike McCoy, a Canadian senior research analyst.
And in particular, the application of the knowledge engineering to
Here, with the international exchange of senior researchers, an example of the invisible university at work. A unique faculty, without walls, either physical or mental. Another vital aspect of the Scientific Affairs Division is the sponsorship of meetings designed to bring together top scientists to teach and discuss specific subjects and technological problems facing our world. About 70 summer schools are held annually, and these courses, which explore the very frontiers of research, take the form of advanced study institutes. Here in the French Alps, Professor Stora directs a typical summer school.
The School of Theoretical Physics at Les Uches was founded in 1951.
Thank you, Professor Lacombe. The topic, as you just heard...
Since the 60s, we have regularly held NATO Advanced Study Institutes. The purpose of these institutes is to assemble some 50-odd students from all over the world and put them alongside some dozen or more lecturers who are all experts in their chosen fields.
To the full wave propagation characterization of the excitation.
Each session endeavors to update the most advanced knowledge in such areas. But perhaps the real achievement of the summer schools is the bringing together of multinational groups of young scientists who all believe in the value of their chosen profession. The students are some of the brightest their respective nations have, and when not at lectures, eat, drink, and talk their specific subject. Those who come here to Les Uches cannot but think instinctively about nature, science, and the future of mankind, and of course how science fits in this future.
Back in Brussels, more to plan and administer, as staff schedule this year's advanced research workshops. Here at Limone in northern Italy, a workshop is underway, one that looks at current medical research into something that interests us all, longevity, just why we grow old. At such international meetings, small numbers of experts meet to discuss their own top-level research programs. Some 100 kilometers away, in the lovely Villa Olmo, on the shores of Lake Como, another get-together.
Where J is a conjugation.
Here, an interchange of ideas that helps to foster the individual qualities of the scientist and keep him abreast of current thinking. So far, over 150,000 scientists have participated in hundreds of summer schools and workshops. Their discussions have led to thousands of books, articles, and papers, which have become vital reference works. But probably more than anything else, their workings have led to the spread of ideas, research programs, and ways to increase man's understanding of our ever-changing, ever-demanding world.
Item calls for a thorough discussion of our Science for Stability program.
In recent years, a special program designed to strengthen science and technology in Greece, Portugal and Turkey, 3 alliance countries with the least developed economies, is in full swing. Today, Science for Stability handles more than a dozen projects, ranging from biology to combustion of coal, from food technologies to digital communications.
The floor to the representative of Greece. Thank you, Chairman.
Greece, the land of 1,000 islands. Here, a country that has long depended on the sea for its commerce and much of its food. But today, fish stocks are vastly depleted, whilst demand grows. A project was established to study fish populations and fish ecology, one that led to the building of a new class of fisheries research vessel. This study is under the direction of Commodore Koliniatis of the Hellenic Navy.
A keel is laid in a small shipyard in Piraeus, and, as is the Greek custom, the keel and the boat are blessed. Blessed for good fishing, good luck. But the trawler is something new in Greek waters. It represents a unique contribution to our fishing industry. My role is to see the project through to the day when the boat is sailing, researching, examining and monitoring the fish population of the local waters. The trawler is a floating scientific platform on which up to 8 scientists can sail, test and evaluate fish stocks. Fishing is a vast industry employing many thousands of people. It is a hard life. Much is done by small boats, kayaks, which are often owned by families. I often join such boats and see what is happening and to try to understand their problems. The new research vessel will discover by hydroacoustic techniques what triggers the movements of certain species. We will also investigate the density of the fish population and obtain accurate data on their size and age. Such matters are vital to a fishing industry that is in a period of change. But tomorrow we will see a boat that is unique. A research vessel specially designed to study the sea, the fish, the weather, and all the environmental issues that combine to make fishing a more profitable and efficient Greek industry.
Continuation in an amplified frame. I would like to assure the committee of our warm support for the continuation and strengthening of the program. Thank you.
Thank you, Mr. Chairman. Turkey attaches great importance to the 2 main goals of this unique program, namely, the expression of the political solidarity within the alliance.
Turkey, where East meets West. Europe borders Asia. A nation self-sufficient in producing food for its peoples, but with the production of foodstuffs comes a problem: the control of molds that produce mycotoxins, detrimental to human and animal health. East of the Bosphorus, by the shores of the Sea of Marmara, is to be found the Gebze Research Center. Here, a team is working on a program designed to identify and control the poisonous mycotoxins. The project manager is Dr. Artemis Kara-Ali.
Alongside my colleague, Project Director Dr. İhsan Alper'den, we have been, for the last 5 years, researching the impact of molds and mycotoxins in Turkish food commodities. Mycotoxins are the toxic metabolites of certain molds which might invade agricultural products and are a threat to the welfare of all human and animal life. They can grow in almost all climates, provided that certain conditions of humidity and heat exist for such growth. Turkey is a large country and one which possesses very different climates. We also grow a wide range of different agricultural produce. So the first thing we had to do was divide the country up for research purposes into 9 regions. The samples of food commodities bearing relevant ecological data are collected from all regions, and the first thing our researchers do is analyze them for their molds. Our microbiologists isolate and identify the molds each sample contains. Over the 5 years, we have accumulated about 9,000 molds and thus have established our own mold collection center. To ensure applicability of project findings, wide collaboration has been achieved among relevant Turkish research institutions, governmental organizations, and private industrial firms. This network is vital for extending to concerned bodies precautions to be taken to avoid mold and mycotoxin contamination at each stage of food production, starting from harvest through processing, storage, transport, marketing, and consumption. We believe that the conclusions of this research project will have a serious impact on Turkey's economic future, on our industry, as well as on the health of our people.
Turkey hopes that the Science for Stability program will be allowed to continue to highlight the third dimension of our mainly defense-oriented alliance.
Mr. Chairman, Science for Stability has already made a noticeable contribution in 2 different and important aspects. Firstly, bringing together academia and industry, developing new links and a new trust between these two.
Portugal, the land of the navigators. Yet one of its industrial problems occurs in the bowels of the earth. South of Lisbon, cutting across the Iberian Peninsula, is the plain of Aljustrel. Here, there is a geological formation containing rich deposits of pyrites. There are several working mines at Aljustrel, where hundreds of meters down, miners blast out the iron and sulfur ores. The ores travel to a chemical plant, a Dante's Inferno of smoke, heat, and steam, to make sulfuric acid, which, when treated with phosphate deposits also found in Portugal, yields fertilizers vital to the nation's agricultural production. But more than this can be obtained from the mines, for pyrites contain significant amounts of copper, lead, zinc, and other metals, including small amounts of gold and silver, which, if they can be economically recovered, would be sold on the world markets. A project to investigate the treatment of the complex ores is underway. The National Programme Coordinator is engineer Trigu Dabro.
The project, based upon previous research done by several bodies in Portugal, has the added advantage of having brought together researchers from a national lab like LNETI, industrialists from the big chemical holding Quimigal, and mining experts from the owners of the pyrite mines at Aljustrel. At LNETI, the National State Laboratory for Industrial Research, several teams of researchers are now trying to find out new methods for extracting from pyrites metals like copper, zinc, lead, silver, and so on.
Or do you intend to shorten?
All working together for the vital task of modernizing the mining and the extractive industries of Portugal. This will give our mining a new outlet. Sulfuric acid production on the basis of pyrites is no longer a commercial proposition, so the companies involved embarked in a scheme to develop new commercial products from pyrites. But the new metals that can be extracted correspond also to a pressing need from the European and world markets, and will generate new industrial opportunities for the region.
Whether in Portugal, Turkey, or Greece, project directors, scientists, and engineers, supported by experts from other alliance nations, have combined to combat problems vital to the economic development and national well-being of the three countries. The major impact of such progress is not so much what it replaces, but what it makes possible. But there came a time when many looked at today's rapidly changing world and wondered just what was being made possible. On the agenda of NATO's 20th anniversary meeting in 1969 was a proposal requesting the alliance to take on a new social dimension. And from that stemmed a new independent committee entitled The Challenges of Modern Society, CCMS. For those involved, the tasks ahead were as challenging as the committee's title: vast and widespread. Today, CCMS confronts problems ranging from water and air pollution to aircraft noise, from maritime and coastal pollution to tackling forest fires. The rolling thunder of an ever-changing, all-consuming world creates its own very special problems. In Cologne, deep in the heart of Europe, stands one of the world's largest Gothic cathedrals, an edifice that took over 630 years to build, but it has taken only 30 years of acid pollution to damage seriously the cathedral's priceless, centuries-old stained glass windows. A team of scientists looked into the problem, and their findings amazed them. For glass that was once over 3/4 of an inch thick had been reduced to 1/4, and many pieces were falling out. In the cathedral's workshops, craftsmen began the meticulous, slow process of cleaning, matching, and replacing damaged segments. It became a jigsaw puzzle of an effort to save a vital part of Germany's cultural heritage. On completion, the windows are sandwiched between 2 layers of protective glass and returned to their rightful place. But the entire process was deemed long, costly, and aesthetically displeasing. A new remedy had to be found. East of Cologne is the university city of Würzburg, and here an institute that deals in the chemical durability of glass. After 3 years, scientists made significant progress towards protecting medieval stained glass from acid corrosion. Research that led to the discovery of a liquid coating. Tests carried out on spread segments of historic glass simulate solar, wind, rain, and weathering aging conditions. The coating devised offers a safeguard for at least 50 years, and of course it can always be done again. A magnificent heritage is being protected for present and future generations, whether in Cologne or in Brussels, for here too the same problem at the Cathedral Saint-Michel. The results from Würzburg are available to all, and they, alongside other research programs, combined to preserve the stained glass windows in many of Europe's great cathedrals from man's self-made damage. From the past to the future, miles away from man's early hymns to the glory of God, is one of the world's most modern industrial research establishments. Here, scientists tackle light of a very different nature as they probe the many mysteries and uses of the laser. But whether in New Jersey or Würzburg, the same tireless effort to produce, discover, and make viable new materials, new ideas, and meet new demands. Today, the need to remain in harmony with our rapidly changing world is as vital as ever. For all around us, the challenges are great, the opportunities too. They can only be met by painstaking, meticulous research and teamwork, in which the pooling of ideas, industrial resources, talent, and the international mobility of the scientist all play a vital role. Science, as an expression of man's innovation, ingenuity, and curiosity, is NATO's key to keep our world in the forefront of human progress.
So let's have a shot coffee break.